Last question of this very awful no calculator section. It's so hard, and now we get this crazy looking thing. But let's just follow instructions, okay? We are being told a lot, but we can kind of take it one piece at a time, right? So first and foremost, we're being told there's a triangle, but I don't see a triangle. So my instruction, it's implied, is draw one, right? So ABC, the measure of angle B is 90. So this has got to be my B, and then let's just do ABC like this. BC is 16, and AC is 20. Okay, there's my triangle. Triangle DEF is similar to triangle ABC, where vertices D, E, and F correspond to vertices A, B, and C, respectively. I'm going to stop right there. So I'm just going to draw another triangle that looks kind of similar, and they're saying they correspond. So DEF and ABC better line up. So A is the same as D, E is the same as B, so that's my right angle, and F is the same as C. Right? That's what it means when they say they correspond respectively. It means they're matching up in the order they're listed. Okay. Whew. That's done. And each side of triangle DEF is 1/3 the length of the corresponding side of triangle ABC. So that's annoying because 20 is not divisible by 3. Neither is 16. So there's a couple ways to handle this. The best way is to have enough experience with trigonometry that none of the numbers that they give us matter at all. So let me show you what I mean. First and foremost, sine of f. Let's look at that for a sec. We know that SOHCAHTOA, let's do it down here. Actually, yeah, let's do it over here. SOHCAHTOA. This is our way of memorizing the different trigonometry functions. And so sine of f means we're going to use this one. And so the sine of f is going to be the opposite side, the O, over the hypotenuse, the H. And so if we look at that, that's going to be, for our purposes, the value of DE, which we don't know, over DF. But the most important thing to know about trigonometry is the reason it works is that we don't actually care most of the time about the lengths of the sides. Because everything about trigonometry is ratios, and ratios are fractions, and fractions reduce. So what we're always doing with trigonometry is we're dealing with the fraction, and we can, 1/2 and 2/4 and 3/6, they're all the same fraction, even though they have different numbers. And so these numbers right now are really weird. So what I would do is I'd say, well, man, it would be great if I could create another triangle that has easier proportions. And because I've experience, 16 and 20, those are not coincidence numbers. Okay? The other number that goes with them is 12. Now, where did I get that from? Well, it's because on the SAT, especially on the no calculator section, the most common relationship for the sides of a right triangle when we have trigonometry is 3, 4, 5. So that's what we have here. We have 3, 4, 5 triangles. Now I could have found that 12 using Pythagorean theorem. So I could have done, let me do it in red here. I could have done AB squared plus 16 squared is equal to 20 squared. And I could have solved all this. Even without a calculator, these aren't so bad. 20 squared is 400, 16 squared is 256. It's annoying, but it's doable. But I don't have to do that because I'm always on the lookout for 3, 4, 5 triangles. And that means that if a triangle gets bigger, but it's in this proportion, the same relationships are going to hold between sine, cosine, and tangent. So let me show you. What did we do? How did we get from this blue triangle to this red triangle? What's that move? Let's use this color to show it. Well, it's easiest to see with 5 and 20 because 5 times 4 is equal to 20. 4 times 4 is equal to 16. 3 times 4 is equal to 12. So it's a ratio. So that's what I meant before, where it's the same kind of fraction over and over and over again, but it reduces. So the same thing is going to happen with this green triangle with the weird numbers. Is I don't really want to deal with the weird numbers because the weird numbers are going to be a fraction that reduces to the same 3, 4, 5 triangle because all of these triangles are similar. They have the same proportion, the same ratio, the same fraction. If this is confusing, you might want to go back to some of the trig basic stuff on Khan Academy. This is like a little confusing, but if you can get this, then all trigonometry kind of just like makes sense. It just makes makes things much easier. So what's going on here is I'm really trying to compare side AB to side AC when I'm asked for sine F, because the sine of F, because all these triangles are similar, is equivalent to the sine of C. Sine of C. It's also equivalent to, let's call this X, Y, Z. It would also be the sine of Z. And so in those numbers, sine of Z is going to be, opposite is 3, hypotenuse is 5, 3/5. That's the answer. Now, if I continued it with AB, that would be 12 over 20. But, right, that's a fraction that can be reduced, right? Because 12 is divided by 4, and 20 can be divided by 4, and the 4s would cancel, and look what we'd be left with, 3/5. Because they're the same triangle. They're just bigger and smaller, but the proportions are the same. So the relationship, the fraction, is always going to reduce to the same thing. So this looked crazy, and my explanation kind of went in lots of different places because I was trying to teach you trigonometry while I was trying to explain this question. But if I saw this on a test, I would have gotten to 3/5 in just a matter of seconds because it's so, I do know that, it's so ingrained, and so I'm looking for the 3, 4, 5 triangles, I spot one, and the rest is just plugging the right numbers in the right places. You can get that good. Trigonometry in the SAT, one good thing about the SAT is it's not testing a lot of trig. It's not like the ACT. So if you know these few rules that they test and you know them well, every trigonometry question is kind of going to start to feel the same to you. So that's a good thing. We don't want to have to memorize too much. And SOHCAHTOA is the main thing for the SAT. So if you can get that down, if you can understand that these are fractions, you're probably going to get 95% of trigonometry questions right with just that rule. So take the time, memorize it, and you'll guarantee some points.